Real simple, okay? Now, I had a student whose mother and I got into it one night at parent-teacher conferences. I know that's a shock. But the student didn't take notes. And the mother wanted to know why. And she wanted to know why I didn't insist on her child taking notes in my class. And I said, well, because I don't care what your child writes down. You know, it's your kid, not mine, as long as he understands the material. And he looked right at his mom and he goes, Mom, it's easy. If I don't understand something, I'm just going to go click play. Why would I write anything down? Now, it's kind of a fine line, though, simply because it's one of those things that there's a Chinese proverb, and I think Coach Arnold has it, and listen, am I hanging on his wall, right up by his clock. Does anybody know what it says? You ever paid attention to that? It's right up by his clock.
No, not really.
It's something about like, tell me and I forget, involve me and I do this or whatever. The more times you write it down, the more likely you are to what? Remember it. So, it's relative, but I don't care. If you don't want to take notes, don't take notes. It's your education. It's not mine. I've been there, done that, bought the t-shirt. So, just kind of keep that in the back of your mind. Alrighty, so it is 9/18 today, correct? Yes. This is going to be SM2H Unit 2, Day 1. And our objective is going to be able to understand and define the rules of exponents. Now, I'm gonna be brutally honest. This is probably my least favorite section in this entire unit. Straight up, my least favorite section, and because it's kind of boring. Which is, let's face it, it's math first, right? Now, granted, most of you like math, or you wouldn't be in an honors math class, right? And I'm a really good teacher, so I mean that also. Why was that funny, Becca?
I smiled. And
it sounded to me like you giggled, which like, yeah, whatever.
It was a nose laugh.
It was an agreeing laugh.
Yeah.
Oh, an agreeing laugh. Nice save. Yeah, you probably ought to pay him later. Okay. Was there something from the back?
Probably. I didn't hear.
You didn't hear? I thought I heard something. Anybody back there? No? Snyder, did you comment? No. Okay. Alrighty. Now I have actually kind of taught a lot of this already. So for example, if I have, x to the 4th times x to the 5th, what am I going to get? I'm going to get x to the 9th, right? Now, you've all done that. But did you know it actually has a name? It does. Yeah. It's like your Barker, right? It has a name as well. And it is called the product rule. Now, if this was chemistry, which I'm going to assume I'll teach most of you in next year, because that's usually what happens, things are way more tied to their names. In math, I'm going to be honest, I'm not sure I really care that you know the specific name. What I'm more worried about is, can you do what? Yeah, can you apply it? Can I apply that rule? Well, it's called the product rule. Now, here is where the product rule gets about 30% of the students. Okay, so what did you just say?
9 to the 11th.
9 to the 11th. That's 30%. What's wrong with that? Becca?
You have to leave the base the same.
Yeah, the base, when we times x, did that x change? No. This should just be 3 to the 11th, because the only way I'm able to add those exponents is if the base is the same. But if I change the base, now I'm drastically changing that. Let me explain. Let's say I take 3 to the 11th. So I take 3 to the 11th, right? That's that. Now let's say I take 9 to the 11th. Whoa. 9 to the 11th. I don't know. Are they a little different? By like a factor of 1,000,000. I'm just saying. Just a bit outside. But yeah, so you gotta remember, and I don't know what it is, and I don't know if it goes back to, and I don't mean to single you out, Barker, because that has been every year. That never changes. Okay? I don't know what it is, but in doing the exponent rules, it's like in the past, they've never really applied them to regular numbers. You've always done it with just variables, so it's easy to see. But the minute they put a number as a base, you're like, oh, well, I got to times them together. And that's what I would say that I get that at least 50% of the time. Yo.
In polynomials, so wouldn't we multiply those two numbers?
Okay, now, okay, but you got to remember the difference is, and that's actually a great question. The difference is that's when I had a number and a variable.
So if you have a variable, then you multiply the numbers. But if you don't,
Exactly. Okay, that's a great question. So let's say I looked at this. Let's say I went 9x to the 4th times 3x to the 7th. Then, because now the product rule is only being applied to those two things. The other numbers are just multiplying. And that's where I'm going to get 27x to the 11th. You see what I'm saying?
but if there's no x,
Exactly. Then I don't. Okay?
But then how do you do it if it's like just 9 to the 4th times 3 to the 7th? Would he not?
Okay, now you are way muddy in the water. Like, I mean, like you're just like tearing it up and just like throwing crap everywhere. But I can teach you that because that's a great question. Now, who can tell me what is inherently wrong with that? Yeah, they're not the same bases. Or are they?
well, they do have.
Now, okay. So this is why I was saying muddy the water. Now let me explain something to you. On its surface, can I do that problem? No. Why? Because technically these are not like bases. One's a 9, one's a 3. I can't combine them. But we're in honors math, which means we're all a little smarter than everybody else, right? Is that not true? Okay. So what is 9 really? Does anybody know? It's 3 to the second. So I've got 3 to the second to the 4th times 3 to the 7th, right? Well, this is a rule we haven't talked. I talked about it one day, but today we haven't talked about it. Who remembers what this was? No, I was. Were you drinking?
Yeah.
Oh, sorry, I didn't see that. Yo. What?
Raising the exponent?
Yeah, but do you remember what it's called? It has a specific name. I thought I mentioned this the other day just in passing.
Power?
Oh, did you have that written down?
Yeah.
Ghost fist bump. Bam. Yeah, it was a power to power. What did I do to them? I times them, right? So that is 3 to the 8th times 3 to the 7th, which is 3 to the 15th. Again, my base did not what? Base did not change. Now, not very often can I do that. And that, the reason I said muddy the water, because we haven't covered that yet, but does that make sense now?
Yeah.
And that's how you would do it. They've got to be the same base.
So if 9 or that number that where 9 is
You can't do it.
divisible
No.
by 3, then
Yep, exactly. Exactly. Yes. Yes, Flinders.
Could you change the 3 to the 7th to the 9? Could you do that? Would that
No.
be the same?
Well, you could, but the problem is that's an odd exponent, and I wouldn't be able to go. I can't. Let me put it this way. So let's say I had 9 to the 4th times 3 to the 6th, right? Well, 3 to the 6th is 3 to the square to the 3rd, right?
Yeah.
Now that's 9 to the 3rd. Then I could do it that way. But when it's an odd, I can't do that.
Okay.
Because I can't pull a, you know what I'm saying? I can't divide it by 2. So, but yeah. But that's a product rule. I mean, you've all done it a lot, but they want you to know that it has a name. And so they could ask you, hey, what is the product rule? When I take two bases, like bases, that are being multiplied together, I simply do what? Add the exponents. That's what they're getting at. Does that make sense? Okay. All right, now that's a product rule. Now, the next is the distributive rule for exponents. That was supposed to be a D, but it looks a lot like an R. So the distributive rule for exponents. Now, so what's going to happen here is if I have, x times y to the 7th. Okay, and again, this is x times y to the 7th, not x what? Plus y to the 7th. Entirely different animal. This is only if they're multiplying. Anybody know what I do with that 7? Yeah, I basically take it there, and I take it there. Now, right now, what is on each of those x and y's?
1.
There's a 1, right? So when I do that, what is that 7 going to do to that 1? It times, because then it's just like the what? What did I call it? Orgeson? Power to power, right? So 7 times 1 is going to give me x to the 7th times y to the 7th, right? That's basically like a power to power thing. Now, how else could I have written that? Does anybody know? Just x, y?
Yeah, it's multiplying. Like, there's no times.
What?
Like, can't you just take out the multiplication sign?
Well, yeah, but I mean, is there another way I could rewrite this is what I'm saying?
I don't know.
Yeah, the answer.
Well, think about it. When I had this squared, what did we do? Last unit.
You put another one right next.
I put another one right next to it, right? Well, in this case, I would have to put 7 of them. X times y, x times y, x times y, x times y. Yeah, the minute I wrote that 7 down, I thought, I'm an idiot. Oh. Some of you are like, well, we already knew that. Yeah, I'm watching. You laughing, you're getting an F.
I'm not lying.
Oh, that's a lie.
No.
She's not only laughing, she's lying about it. Okay, yeah, I could do that. A lot of different things I could do there. Why you would ever do this instead of that is beyond me. You know what I'm saying? I mean, but you are teenagers, so sometimes you do require to do things the hard way. I definitely don't want to do it the way my parents told me to do it, so I'm going to do it the hard way. And that's like fact. I had 2 of them, and believe me, I know what I'm talking about. Okay? So let me think of another example we could do there. What if I did this? Let's say I did 2 times 7 times 5 to the 3rd. How would I do that? Okay, so you're saying I could just do this math first and then take it to the power?
That's what it says to do.
That's what it says to do, does it? Where does it say that?
You're supposed to do parentheses.
Oh, you guys are referring to this? Oh, please excuse my dear Aunt Sally? Yeah, PEMDAS. Okay, parentheses, exponents, multiply, divide. I could do that. You're right. But parentheses and exponents are what? Does anybody know? They're actually interchangeable. I could do exponents and parentheses depending on the situation. Now, if I was doing this, you're right. I would times them, take it to the 3rd power, I'm done. But what else could I do? Yeah, I could go and I could do that, and I could do that, and I could do that, and I could go 2 cubed times 7 cubed times 5 cubed. I could still do that, right? Or I could do 2 times 7 times 5 times 2 times 7 times 5 times 2 times 7 times 5, right? There's lots of different ways I could do this. It's like the old expression, there's more than one way to skin a cat, right? How many of you have heard that expression before? Oh, way more than last year. Good job. Okay. But all these are different ways of really doing the same thing, which is why, and I don't remember if I talked to you guys about this or if it was my 5th period, but if you've had a teacher in the past that taught you okay, let me rephrase that. I just about said a better way, but whatever. That taught you a different way and you like that better, by all means do it. But it better work every time. You know how sometimes teachers will teach you little tricks and stuff?
They work 1% of the time.
That work some of the time. We don't do that. If it doesn't work all the time, I ain't teaching it. Okay, but if it does, feel free to use it. I don't care. Okay? So yeah, there's lots of different ways of doing that, and that is another way to do it. But yeah, parentheses and exponents are interchangeable. I could go exponents and parentheses. Just like multiply and divide. I could divide before I multiply. It just depends on the situation. Okay? Does that make sense? Yeah? Alrighty, so from there we're going to go to the quotient rule. Now, quotient. Who knows what quotient means? Yeah, quotient equals division, right? It's kind of like, I believe it was Dixon that asked me how to do that problem when above it said product.
Oh, yeah.
That was you. See, right here, elephant. Yeah, that's a lie. I forget everything. Okay, quotient means division. So if I have x to the 4th divided by x squared, what am I going to get? Does anybody know how to do this? Becca?
X squared.
Why?
Because you subtract the top exponent from the bottom when their bases are the same.
Okay, now, can anybody relate that to something else we've already done? When I multiply, I do what with my exponents? I add. So logically, division is the inverse of multiplication, right? So if I'm going to divide instead of adding, I'm going to do its inverse, which is subtract. So it basically becomes x to the 4 minus 2, which gives me x squared. Does anybody know the old school method to do that? Dude, did you just ask, is there an old school method?
Yeah.
Well, of course there's an old school method. Always. Like I'm older than you, so there's an old school method. Yo,
Where you write out all of them. So you
don't
write
steal
out the ones.
don't steal my thunder.
Just ask the questions, so I answer.
Yeah, but that was rhetorical.
Oh,
Gee.
I know what you're talking about now.
Oh, so see,
Yeah.
so yeah, so if I had, x to the 5th over x to the 3rd, I'm going to take, x to the 5th could be written as x times x times x times x times x, right?
Oh, this is football. They cancel each other out. The 3 take the 3, so there's only 2 people.
He's really, really close.
They don't
Okay.
actually divide each other out. So
Now, okay, so one thing you will learn is I don't like that word.
Well, we're canceled.
Cancel. Because to me, cancel gives you a what?
0.
A 0. But in division, if I've got a 0, do you see how that screws with my problem? So I prefer reduce or simplify out. So that's going to reduce, that's going to reduce, that's going to reduce. I'm going to be left with x squared. And who used the football analogy?
I learned it in 7th grade.
But that's what I'm saying. From who?
Name was Shaw. Mrs. Shaw.
No.
From Walquist?
Yes. Yeah.
Don't know her.
From George.
What?
I said I learned it from George.
Who's George?
From August. Mrs. George?
Is it Krista?
Yeah.
Yeah, her kids played here. I know who you're talking about. She had my older son. Alrighty. So, I mean, that's another way. Because apparently there is old school ways. Okay. But yeah, I mean, I look back. This is the only way I was taught. I was never taught that, I can just take that minus that and there's my answer. Now, when could that cause a problem?
When there's a
When you
long.
end up
There's
with a
a
negative
more-
exponent on
there's
the
more
bottom.
on the
you need to
bottom.
write it down.
More on the
Yeah, when my denominator, you see how I didn't say anything until someone said, we don't say top and bottom here. It has a name.
I fixed it.
I know. I'm just pointing it out. If it's the last day of school and I'm still saying, hey, you, would that bother you a little bit?
I'd accept it.
It depends.
Dude, it pissed me off. I have a name. You should learn it. I've only been in here 90 days. Now, so what I would say is, what if I've got x to the 3rd over x to the I don't know, let's go 8, right? Did you really say 17? Leave it to Parker to just throw something out there. Now when I do that, that's going to give me x to the what? Negative fifth. Now, okay, now, this is, remember how when I said that they're going to kind of change things a little bit, which is why I taught it, and then I thought, you know what, I'm not going to teach it that way. This is an example of that. Now, the difference is they are not talking polynomials anymore. You're right. This would not be a polynomial, but it's still doable. Yes, Anglesy.
I know how to do this.
Awesome. Why don't you teach us?
Oh, you gotta put the x minus 5 in the denominator and put a 1 in the numerator.
Okay, you're absolutely correct, Sarah. I didn't like how you said that. It's not x minus 5. It is x to the negative fifth. Is that? But no, I'm serious. You understand what I'm saying, right?
Yeah.
So if somebody doesn't see what I've written down, they're going to hear that and they're going to think you literally mean x minus 5. Does that make sense?
Yeah.
Yeah. But she is exactly right. It's in the numerator, right? But because it's a negative, it tells me to move it to the denominator, and then that negative goes away and it becomes 1 over x to the fifth, which is okay, but you're right, it's not a polynomial. Does that make sense? But I can still do it. Okay? Now, let's say I did this. Let's say I went 5 to the 7th divided by 5 to the 10th. What would that give me?
1 over 5 to the third. 1 in the numerator and 5 to the
No, that's just a 10. That's just a 5. Yeah, I can see how you could think that way. I've come to terms with the fact that my penmanship sucks, so you will get really good. Ask your sisters. Yeah, I mean you get really good. Really, initially it would have been 5 to the negative 3, right? But like Anglesy says, it's going to become 1 over 5 to the third, right? But they're never going to want you to leave it like this. Because do you have the technology to do that math?
Yes.
Yeah, do it. And don't, whatever you do, say 15 or I will freak out on you. Like, I mean, start twitching stuff. $125. You know someone thought 15 because that's what they do. I'm just
5 times.
nope. Nobody wants to be.
I've done that before, but not this time.
Okay, but you know what I'm saying, right? You just automatically go, oh, it's a 5 and a 3. That's 15. Okay. Alrighty. Now, that's that. Now, what if I did? So now we got to talk about the 0 rule. Okay. So what if I have 7 to the 0? It's 1. What if I have 1,000,000 to the 0?
1.
It's also 1. Now, does anybody know? So this is what I used to do. I used to write down anything to the 0 is 1. But that is not entirely true.
0 to 0.
Yeah, except 0 to the 0. Does anybody know what 0 to the 0 is?
0.
Bro,
That's a good guess.
it's error.
It's undefined.
It's error on the calculator.
Is that what it comes up with? Is a syntax error? Okay. Yeah. 0 to 0 is undefined. It is the only thing that when taken to the 0 power does not give you a 1. So anything to the 0 is 1 except 0 to the 0, then it is undefined. Okay? And they're going to walk you through some of those yada yada yadas. Okay? Alrighty. Now, we did that out of order. Dang it. Oh well. It's her fault. She's the one that brought it up.
Me?
Yeah.
Oh, I'm sorry.
Well, technically you didn't bring it up. You just told us how to do it, which kind of took me off somewhere else, but it's okay. It was actually, it was kind of my fault, but I'm going to blame you for it. So,
Oh, okay.
yeah.
I'm okay with that.
All right. So, last thing we need to talk about is a little bit of power to power. What happens if I have this? Yeah, my base still doesn't what?
Change.
My base still does not change. I simply take that times that, and I'm going to get 4 to the 10th. Now again, if this is reasonable, do it. I don't know what 4 to the 10th is. I'm guessing it's a large number. Anybody got it? Have I not mentioned that you should bring a calculator to class every day? Have I not said that? I have. Well, then why don't we all have a calculator? I got one kid. Erp, right? Yeah, Wyatt's the only one prepared. Sorry.
It's a big
I think I
number.
told you, though, I might call you that one day, huh?
Yep.
Yeah.
It is a big number.
It is. What do you got, Barker?
1048576.
1048576.
Yes.
Anybody else get that? 1,048,576.
Oh, damn.
Close to my IQ. I'm not sure why that was so funny. You get an F, and you get an F, and anybody that laughed gets an F for today.
I really did
I
not
was
laugh.
laughing.
I really didn't.
She
Hadley.
actually didn't. I didn't hear her.
So
Shh.
do you want us to write it like that, or can we do?
Now, what I would do is I would do stepwise. I would write this because let's face it, that's what you're going to do. I don't need to know if you can punch the buttons on your calculator to get to that. If it's something simple like the 5 to the 3rd, yes, I would expect you to do that. But if it's something like this, I mean, I can't do that in my head. I don't, you know what I mean?
Yeah, I'm saying like 4 to the 10th or 16 to the 5th. They give you the same answer.
Oh, yeah, so they would want this there because they're practicing this multiplication.
Okay.
But yeah, I see your question. Yeah. Okay. That's pretty much it.
Nice.
Any questions? Comments, concerns, funny jokes,
I'm sorry I stole your thunder.
good anecdotes? Yo, Anglesey.
You know that Yoda has a last name?
They did?
Yeah, Yoda has a last name.
What was it?
Leahy who.
Oh my gosh.
Oh my gosh.
Stupid as heck, but it was, I mean, get it? I mean, it was a little, nobody else thought that was just like a little funny? I did, and that's all that matters, so it's okay. Okay, let's go. Get busy. You got, what time do you get out of here? You got 25 minutes. 20 minutes.
Is it like how long do you have?